The topic of the video is interaction of light with matter with dipole approximation. When light with electric field E with polarization along Z direction with amplitude E naught and frequency omega actually interacts with an atom which could be having a dipole moment, the electric dipole moment, and then electric quadrupole moment, and magnetic dipole moment, magnetic quadrupole moment, etc. The case in which we only consider the dipole moment of the atom into consideration is the approximation, which is called the dipole approximation. And in this case, the interaction energy is taken as negative, the dot product of the dipole moment P of the atom and dotted with the electric field of the applied light. So the perturbation Hamiltonian can be written as negative P dot E, and it will be actually dependent upon time because the electric field now is oscillating as a function of time. When we substitute the expression for E field from here, it can be seen as equal to negative E, the charge of electron, and then E naught, the amplitude of light, and Z, the coordinate, and then cos omega t. But the time dependent perturbation theory actually gives the amplitude of probability for transition of the atom from the energy level n to the energy level m as this integral. And if you substitute the perturbation Hamiltonian from this expression, and if you do the integration just the way we had in the case of the harmonic perturbation, we'll be having two terms in this expression for AM1T. Here the second term will actually kind of dominate when omega will become omega sub mn, and that's because omega that's what will imply em minus en is equals to h cut omega, and we can see that as em is actually bigger than en by a factor of h cut omega, it means that the energy of the atom has been raised, and in the process the energy of light is lost, so it can be considered as the process of the absorption of light between the energy levels of the atom. And the first term in the expression of AM1T will be dominant when we have the case of omega being equal to negative of omega mn, and in this process we see that En will be Em plus h cut omega. That means the energy level n is actually kind of bigger than energy level m by a factor of h cut omega. So in this as we have transition from n to m, it is actually kind of logical to consider that from upper level to lower level we have a transition, and this is kind of the process which is called the stimulated emission process in the atom. That's it in this video, and thanks for watching.